Hey scholars, hope you had a great fall break. We are going to start a new unit called Polynomial Operations. For this lesson, we're going to learn how to classify polynomials based on their characteristics, and we'll also discuss how to add and subtract them. So make sure you pay close attention, take good notes. Let's get started. So let's introduce monomials and polynomials. A monomial is a number or a product of numbers and variables with whole number exponents. So some examples of monomials are 3x cubed, 2ab, x to the fourth, or just y. And some non-monomials, some examples that are not monomials, are 3 to the x power because it has an exponent that is a variable. It needs to have a whole number exponent. So that makes this not a monomial. Also, 3 to the 1/2 power. That has an exponent that is not a whole number. So this is not a monomial. Now a polynomial is a monomial. So for example, 3x cubed, that's a monomial. Or it's a sum or difference of monomials. So we have a sum of monomials here. 3x cubed plus 5x squared plus 2x plus 2. So each monomial in a polynomial is a term. 3x cubed, that's just one term. But here we have 3x cubed plus 5x squared plus 2x plus 2. Well, that's 1, 2, 3, 4 terms. So that's a 4-term polynomial. Now let's talk about the degree of monomials. The degree of a monomial is just the sum of the exponents of its variables. So let's check out 3y cubed. Well, the variable is y, and it's raised to the third power. It's cubed. So the degree is 3. Now for 7x squared, y cubed, z to the first power, we're going to look at the three variables, x, y, and z, and then just add up their exponents. 2 plus 3 plus 1, well, that's 6. So it has a degree of 6. Now 12, we don't see a variable there, right? We could even say, just for example, that's 12 times x to the 0 power, because x to the 0 power is 1. So really the degree here is just 0. So that's the degree of monomials. Now to find the degree of a polynomial, we look at the degree of the term with the highest degree. So here's some examples of that. We have x squared minus 2x plus 3. Well, the term with the highest degree is x squared, and the degree is 2. So for this example, 4 plus x to the 7th power, the highest degree of these terms is 7, so the degree of the whole polynomial is 7. Now, when a polynomial is written in standard form, its terms are written in descending order by degree. So here's an example of that. You can see that the degree of each term is decreasing as we read this from left to right. So this example we just looked at, 4 plus x to the 7th power, that's not in standard form. In standard form, it's x to the 7th power plus x plus 4. Now the leading coefficient of a polynomial is the coefficient of the first term when the polynomial is in standard form. So let's look back at this example. The leading coefficient of 5x cubed plus 8x squared plus 3x minus 17, the leading coefficient is 5. So, say the leading coefficient, well, that's 5. Now let's discuss how to classify polynomials. A polynomial can be classified by its degree and the number of terms. So, we have a couple examples here. 5x plus 2. Well, the degree is 1, right? That's x to the first power. So the degree is 1. So I can see, since the degree is 1, the name using the degree is linear, and it has 2 terms. So 2 terms is binomial. So this is a linear, because of its degree, binomial, because it has 2 terms. Now another example is 5x squared plus 3x plus 4. Well, remember quadratics from our last unit. We see the highest degree is 2. So if the highest degree is 2, it's a quadratic trinomial. It has 3 terms, 1, 2, 3. So we'd say this is a quadratic trinomial. So I encourage you to copy on this chart Understand that if a degree is 0, it's constant, if it's 1, it's linear, 2, quadratic, 3, cubic, 4, quartic, and 5, quintic. Okay? So that's based on the degree. You see examples here. The number of terms, if it has 1 term, like we talked about earlier, we have a monomial. 2 terms, binomial. Bi meaning 2. We see a monomial again, based on this example. Now, if it has 3 terms, like this example, we say trinomial, like we mentioned earlier. And then, I'll skip that one. Let's look at this one. It's quintic, right? The highest degree is 5. And it has 4 terms. 1, 2, 3, 4. Now, anything past trinomial, so if it has more than 3 terms, so we'll say a polynomial of blank terms. So in this case, it has 4 terms. Polynomial of 4 terms. If it had 7 terms, we'd say polynomial of 7 terms. Okay? So make sure you get these in your notes and you're able to classify polynomials. We'll get some practice with that here. Now let's try this. We're going to rewrite each polynomial in standard form first. Then we're going to identify the leading coefficient, then name the polynomial by its degree and its number of terms. Alright, so let's first rewrite the polynomials in standard form. So we have, the highest degree is 3, so I'm going to say 4x cubed plus 2x minus 1. Now, let's see, we want to identify the leading coefficient next. So the leading coefficient, well, that's just the coefficient of the term with the highest degree, so it's going to be 4. It's basically the first number you see there. So the leading coefficient is 4. Now let's name the polynomial. So we see that the highest degree is 3, so it's going to be cubic. So we'd say it's cubic, and then it has 3 terms, 1, 2, 3. It's a cubic trinomial. Now, let's try this for number 2. We got to rewrite it in standard form first. So let's see, the highest degree is 5. So x to the 5th. The next highest degree is 3. So we're going to say 7x cubed minus 11x minus 2. Alright, so it's in standard form now. The leading coefficient, well, we don't see a number here, right? And that tells us it's going to be 1. So the leading coefficient is 1. And then this one is a quintic, because the highest degree is 5. Quintic, and how many terms does it have? Oh, that's right, it has 4 terms, so we'll say it's a quintic polynomial. Quintic polynomial with 4 terms. Now, let's try number 3. The highest degree is 3, so x cubed, and then the next highest, minus 18x squared plus 2x minus 5. Well, this is cubic because the highest degree is 3, and it has 4 terms. So we'd say the leading coefficient is 1, and then this is going to be a cubic polynomial with 1, 2, 3, 4 terms. Lastly, let's talk about adding and subtracting polynomials. Here's some examples that you can look at on your slides. You remember you should have those slides out. So we want to simplify each expression, and we want to write our answer in standard form. Now let's look at number 1. We see that we are adding what's in the 2 parentheses. So if we're adding, we can just go ahead and drop the parentheses. So 3x squared plus 7 plus x plus 14x cubed plus 2 plus x squared minus x. So if we see addition, just go ahead and drop the parentheses. Now we just want to combine our like terms. Well, I see that the highest degree is 3, and none of the other terms have an exponent of 3. So I'm going to write that first because I want to write the final answer in standard form. I'll end up writing 14x cubed first. And if you want to do this, you can just cross it out so you no longer have to worry about it. So now we see 3x squared, that's the next, 2 is the next highest degree. 3x squared plus x squared, well, that's going to give us 4x squared. And then if you want to, you can just cross those out. so I'll just go ahead and do that. And then I see that I have x minus x next. X minus x. Well, x minus x is 0, so I don't have to write that. So they will just cancel each other out. And then lastly, I'm left with 7 plus 2. 7 plus 2 is 9. So here's my final answer. Now for number 2, we see a minus sign in the middle. So we know we're going to end up subtracting the polynomials. So let's remember that if we see a minus sign there, before we can just drop the parentheses, we need to distribute it. So we'll say 1 minus x squared minus 3x squared minus 2x plus 5. When that distributes, basically changing all the signs within that parentheses. So now I see that the highest degree is 2. So I see these right next to each other, negative x squared minus 3x squared. Well, that's like saying negative 1 minus 3, so that's negative 4x squared. And so I can just cross those out. And then minus 2x, there's no other x to the first term. So I'll say minus 2x, and then I can cross that out. And then we have 1 plus 5. 1 plus 5 is 6. So negative 4x squared minus 2x plus 6. That is our final answer, and it's in standard form as we see the degree decreasing for each term. So I hope this video was helpful for you. Please come to class prepared with questions and ready to learn. Good work today. Thank you, Collegiate Scholars.